Hello, how are you, my dear friends? Today we will discuss the thermodynamics process. So, as we discussed in previous video lecture, what is the process? Process means if a, if a system if a system goes from state 1 to state second. So, this is called the process. And in the thermodynamics, it is of the two type. Process is of two type. One is reversible and another is irreversible process. So, reversible means if we have this is a piston, applied the P external, inside we have gas, inside pressure is P gas and external. In the reversible process, first thing it follows infinite steps at infinite times. Means this is state 1 and if the piston move from here to here, it is a state 2. But from state 1 to state 2 require time, infinite time and infinite steps. Okay? Infinite times and infinite steps. We can say if we use the infinite times, means we can say it is very slow process. Okay, it is a very slow process. Or we can say it is a hypothetical. It is a hypothetical process. Means at any time, reversible means the process at any time goes to the previous state. If process start from this to this to this, at any time process, if the process start from here to here, but at any time process move from here to also here, means the previous state. So this is called reversible process. Reversible means why it is called the reversible, means at any time process, means the system have tendency to attain their previous state. That's why it is called the reversible process. How the reversible processes start? If we pour some particles of sand, one by one. Okay, so as the external pressure increase and process goes from state 1 to state 2 at infinite state. Okay, in the reversible process, it follows the infinite steps at infinite times. It is required infinite time. That's why we can say it is a very slow process. And if it is a slow process and uh, and the system have tendency to reverse back, that's why we can say it is hypothetical or identical process. Okay, so in this process, pressure P external minus P gas is equal to very small changes at any time, very small changes. That's why it is very slow process. Okay, means in the reversible process, system is at equilibrium at throughout of whole process. System is at equilibrium with surrounding. System is at equilibrium with surrounding. Mean system is at equilibrium with surroundings. The second one, it is quasi-static process. Third, it is hypothetical process, and P external minus P gas is very small. We can say it infinitesimal small. Okay. Now we will move from the reversible process. In the reversible process, we have system like this. This is a piston of state 1 and it is state 2. P external, P gas. Okay. In this process, it follow finite steps and finite time. Okay, it is a real process. Okay, it is a real process. And it occurs rapidly. And process takes place against external pressure. Okay, in the irreversible process, system is at equilibrium at only 2 points, at initial and at final state. It is the initial state, it is a final state. Okay, in the reversible process, here in the reversible process, system is at equilibrium at every point. Okay, system is at equilibrium at every point in the reversible process. But in irreversible process, system is at equilibrium at only the initial and the final state. Okay, system is at equilibrium at the final and initial state. So, if the system goes rapidly from state 1 to state 2, means we can say the P external here, the P external is a constant. P external is a constant. That's why the system goes from state 1 to state 2 at very fast, means the rapid action. Or so, and now we will discuss about now we will discuss about now we will discuss about work in thermodynamics. Now we will discuss about the work in thermodynamics. Now we will discuss about the work in thermodynamics. Now we will discuss about work in thermodynamics. Work in thermodynamics. In the chemistry point of view, in the thermodynamics, work is PV work and mechanical work. Mechanical work में electrical, yeah, or we can say it for the non-PV work, electrical work, mechanical work. Okay, PV work. Work work it is if we write the definition about work, it is a form of energy which convert or the transfer between convert or transfer between two or the one state to another state. It transfer the system from one state to another state. It is a form of energy which is responsible. It is a form of energy which is responsible to transfer, which is responsible to transfer system from state 1 to state 2 or initial state to final state. Okay, we already know the system, we already know the work is ordered form of energy. Work is W is ordered form of energy from the previous equation in the last lecture. If ignition CO2 plus H2O and energy, heat and some light. Okay, this heat is responsible for work. Okay, so work can be converted into heat. Okay, Q can, it is the ordered form of energy. 100% conversion possible. Not 100%. It is a disordered form of. It is a disordered form of energy. The IUPAC convention of work. IUPAC convention of work. What it is? We have system like this. Okay. This is the P external. This is the ratio of gas. In the chemistry, we always consider the work of gas. If the gas done the work means expansion happens. If uh, if the work done by the gas means expansion happen, we have system like this. IUPAC convention of IUPAC convention of work. Okay, we have system like this, and it is a piston P external inside the pressure of gas. So if the gas works, my system have done some work, mean the P external and the P gas. In this case, P external is less than P gas, means here the delta V, okay, here against the delta V, but in this case volume increased by some amount. Okay, and if we have system like this, okay, and if we have system like this, P external and P gas, delta V, in this case P external is more than pressure of gas, and volume decreased by some amount. Okay, what we understand by this diagram. Okay, in this case, if the gas done some work means the volume get increased, means it is called expansion, means gas do some work, that's why gas do some work. That's why the expansion happens. Okay, means in this case we can say work done by gas. Okay, in this case we can say work done by gas. In this case work done by gas taken as minus W. And if the P external more means it is a compression. And what we will say? Work done on the gas taken as positive. Okay, taken as positive. And in same case we already discussed about the convention of heat. If the system takes some heat taken as positive and system release some heat taken as the negative. Okay, and work done by the gas taken as negative. Why it's considered as the negative? Let us discuss. Let us discuss why it is taken as negative. Why it is taken as, why the work taken as negative? Let us discuss. Why it is taken as negative? Let us discuss. Why it is taken as negative? Let us discuss. In the chemistry point of view, in chemistry, we considered work done by the gas. Okay, means W is equals to P delta V, but the sign, so P in this case we can measure the P external, but we cannot measure the inside pressure of gas. So if the system, if my system is, if our system is at equilibrium, means P external equals to P gas, but the negative direction. Okay, in this case the P external and the P gas, if it is at equilibrium, okay, mean the P external is equals to pressure of gas which is inside of the system but has a negative direction. So we have to consider this pressure of gas, okay, but we can't measure it directly. That's why we measure P external and put the direction like the negative sign, okay. So in the work formula we write W is equals to minus P delta V, minus P delta V. P, it is P, especially mention the P external, okay, not the inside of the pressure. If we write it like if we write it like W is equals to P gas and delta V, then we can say there is no negative sign here, because if in the question mention the internal pressure, means the pressure of gas directly, then we use this formula, okay. So there is one thing also, as we know previously, the work is path function. Work is a path function, means state 1 and state 2 via this path, means the path 1, via this path means the path 2nd. So it is reversible and it is irreversible. So the work is a path function, so W irreversible and W reversible never be equal. Why? Because it is a path function. That's why the both work is not equal. Okay. Sign convention in the chemistry, thermodynamics chemistry, understanding of the sign convention is a very important things. And in the physics, we always consider only irreversible work, and W is equals to P delta V. That's why no need to put sign here. Okay. So let us summarize our lecture. Today we study reversible and irreversible processes and work. Work have the two types, PV work and non-PV work. Okay, PV work means work against external pressure. Okay, so the convention of work, how we understand the convention of work means it is a P external and it is a P gas. So work is P delta V, but we considered work from inside of the system, but it is impossible to measure the pressure of inside of the gas. But if my system is at equilibrium, if my system is at equilibrium, that means the P external is equals to P of gas but have negative sign. Okay, so if we measure the inside of the system work, and if we write here pressure of the gas and the delta V, okay, so this formula is correct, but we measure P external and delta V, so we use this formula. Okay, and the reversible process means our system is at equilibrium. System is at equilibrium at every point. Okay, and in the irreversible process, state 2. Okay, system is at equilibrium at initial and final state. Second, it is a slow process, and the irreversible, it is a rapid process. Okay, and it follows infinite step at infinite times, and it follows finite step at finite time. So in this case, W should be minus P delta V. Okay, and in this case, W should be the summation of, in the reversible case, W should be the summation of state 1 to state 2 against P external change in volume. Okay, or the, in this case, in reversible case, the work should be the integration of change in volume from state 1 to state 2 against the external pressure. So we will meet in next class.